Hi, my name's Liz Rice from Aqua Security, and today I'm going to talk a bit about user namespaces. So you might know that namespaces are one of the fundamental mechanisms used to build what we call a container. And a namespace gives a process a limited view of some set of resources in the kernel. For example, if you have a process ID namespace for a container, it can only see the processes inside that namespace. If you have, there's another namespace called the Unix time sharing system, or UTS namespace, which is used to isolate the host name. So if you have a container, it's typically going to have its own UTS namespace, and you can set the host name inside that container independently of the host machine. And there's also a namespace for users, user IDs and group IDs, which gives a container or processes that have been put into this namespace a different view of user IDs. And the way this is done is really by mapping a user ID from the host to a different ID inside the user namespace. Now, I've got two windows here onto the same machine, same virtual machine, and I'm running as a non-root user. We can see that my ID is not 0 and my username is Vagrant. And if I try to unshare, let's say, the UTS namespace, I try to run a shell like that, I'm not allowed to do that. And that's because I don't have sufficient privileges to do that. But one of the interesting things about the user namespace is that I am allowed to run that as an unprivileged user. So I'm now running a shell in which I appear to be nobody. If I look at my ID, it's given me this high numbered ID that represents nobody. And this is because I never set up a mapping between the user ID I was on the host and the user ID I want to be inside this namespace. Now, if we take a look at the processes running on that terminal, and I want to do that with information about the user ID. Yeah, so we can see here there are two processes running as Vagrant. So even though I'm nobody here, let's just confirm this by running a sleep. And we'll look for all the processes in that terminal. There's my sleep process, and it's running as Vagrant. So even though from the host perspective, I continue to run as the Vagrant user ID, inside the container, I'm apparently a different user ID. So that's what user namespaces are all about, mapping that user ID from the host into the container. One other interesting thing I could do is map so that my ID on the host becomes root in the container. And there's actually a convenient parameter for this, map root user. That implies that I want to unshare the user namespace as well as mapping the root user. And now you can see I'm apparently running as root. And we can confirm I've got the user and group ID of 0. We could even touch a file. Oops, touch my file. And we'll take a look at that. Looks like it's owned by root. But from the host perspective, and it was created at the same time, but it looks as though it's owned by Vagrant. I even have inside this user namespace where I'm running as root, I even have basically this is all the effective and permitted capabilities in the bounding set. So I can act as root within the confines of this user namespace. One other thing I can do is I can now, because I'm running as root inside this container, I have enough privileges to create a new UTS namespace or any other kind of namespace. If you remember earlier, I got operation not permitted and I tried to do that as a non-root user. And let's just change the host name. Oops, container. I'll spell it right in the end. But if I check the host name from the host perspective, I haven't changed anything. Now, if I quit out of both of my namespaces, I'm back to being vagrant. If I try to change the host name on the host, that's not going to be permitted. So, with user namespaces, I can create a new user namespace even if I'm not a privileged user. As a non-root user, I can create that namespace. Inside that user namespace, I can have root privileges, and I can use those root privileges to create other namespaces. From the host perspective, I'm never root at any point. This is really what's great about rootless containers. You can create containers without needing to be privileged, and the software inside those containers thinks it's running as root. It's got all the permissions it needs, all the capabilities it needs if it needs to run as root, but it's not root from the host perspective. So that's a huge step forward in terms of security. Hope that makes a lot of sense. I hope that's explained something about rootless containers and the user namespace.